Elasticity, one of the cloud's most important capabilities. It does reduce costs, but sometimes it takes a bunch of configurations to do that. So can we make it easier, especially for container services? Hello, and welcome to this episode of Cloud Forward. Today I'll show you the extreme elasticity capability of ACK, Alibaba Cloud Container Services for Kubernetes. To provide users with extreme elasticity, ACK provides rich elasticity policies from resource and application layers. Let's start with the resource layer. When the cluster resources are insufficient, the ACK cluster can use the cluster autoscaler to automatically create new node instances in the node pool. It spawns regular instances and GPU instances on demand with support for multiple availability zones, instance specifications, and scaling modes to accommodate various node scaling scenarios. Now, the benefits from doing so include A. It supports large-scale resource delivery, and it's able to scale up to thousands of nodes within minutes. B. It supports custom scheduler. For example, you can schedule Elastic Compute Service and Elastic Container Instance hybridity, set up pod up scaling order and priority, as well as pod downscaling order. C. It supports scenario-based resource delivery policy like reusing, RI, and Spot. And we also equip it with components like Spot Advisor and Spot Notification to optimize the Spot instance policy. And finally, D. It supports end-to-end event monitoring of elastic scaling, log service, and ACK cost analysis function. On top of that, we provide a more straightforward solution for achieving elasticity by utilizing ECI, the serverless container product offered by Alibaba Cloud, while the ACK cluster maintains a fixed ECS resources pool. The Elastic Container Instance can be scaled up to 3,000 pods in 30 seconds, allowing it to easily deal with unexpected resources demands, such as when your gaming service requires urgent scale-up or a large amount of audio, video, or other data processing services. Now let's look at the application layer. We all know that Kubernetes provides HPA, horizontal pod autoscaler, and VPA, vertical pod autoscaler, and Cron HPA for time scaling. In addition to these, ACK provides integration of KEDA, but we wanted to push the autoscaler experience to further simplicity and to increase the SLA for elasticity. Therefore, we introduced AHPA, Advanced Horizontal Pod Autoscaler. The AHPA solves the elasticity lag issue by predicting the number of pod instances to be used in the future based on the application's history usage. A combination of active and passive forecasting is used to adjust the number of resources instances in real time. Passive prediction predicts the number of pods based on real-time application usage, which can handle unexpected traffic. Active prediction predicts the number of application instances to be used in the next 24 hours in advance, based on the history usage, using Alibaba Damo Academy machine learning algorithms. It's not perfect. That's why AHPA has elastic safety policy that allows users to set the upper and lower threshold of the number of instances in a time period to avoid a possible outsourced scenario. There are several common scenarios in which we recommend using AHPA. For example, periodic events like live streaming, online education, and gaming services. In a nutshell, with all these features from resource layer and application layer, the ACK is elastic enough for you to easily lower your computing costs. If you are keen to know more about the extreme elasticity of ACK, click the link in the description below. And don't forget to subscribe to this channel for more videos of Cloud Forward in the future. Until next time.